The best way to predict the future is to create it. Salah, Cok. Yeah. Alan Kay once said, the best way to predict the future is to create it. Good evening, everyone. Quote from Alan Kay ini sangat relevan sekali dengan artificial intelligence. Dalam konteks AI, prediction is not such. Sorry guys, maaf ya. Salah liatin Mas Firdaus. 2, 2, 3. Alan Kay once said, the best way to predict the future is to create it. Good evening, everyone. Quote from Alan Kay ini sangat relevan sekali dengan artificial intelligence. Dalam konteks AI, prediction is not just about the guessing the future, but creating better decisions through the data. That's why in this project, we focus on customer churn analysis in the telecommunication industry, where the machine learning helps companies predict customer behavior before churn actually happens. And it did smoothly. Moving to the introduction. This project is part of our final progress report for the artificial intelligence course, where we apply supervised machine learning models to predict churn and deliver actionable business insight. Before going on, let us introduce ourselves. My name is Fio Ulaa Octriyanti with the last 3-digit identification number, and my friends. My friend Al-Firdaus Nuzula 008, and there's a Rafi Fahrezi. Say hi dong, teman-teman.
Hello.
And we move on to the objective overview. Okay. First, to predict customer churn using supervised classification models. And second, to compare multiple machine learning models and evaluate their performance. And the third, to identify the key features and that influence churn so the model is not only accurate but also business relevant. For next is the problem overview. In here we have a customer churn is a major challenge in the telecom industry, and the companies often react after customer leave, not before. And missing churners means losing revenue and increasing retention costs. So the core problem is how AI can detect churn early, reduce false negative, and still maintain model fairness and interpretability. Next is we have project workflow in a short form. Our workflow follows a standard AI pipeline. We start with the data acquisition and cleaning, then apply feature engineering and smooth. For class balancing, after that, we built 3 supervised models. There's a decision tree, naive Bayes, and artificial neural network, or ANN. And finally, we evaluate the models and extract the feature importance and business insight. For next, we will explain by my friends.
Okay, thank you, Fia. So first, we're gonna look at our dataset itself. We use the telco customer churn dataset from Hugging Face, containing around 4,000 rows, each with around 50 attributes, both numeric and categorical. So the dataset includes demographic, contract billing, and surface usage information with churn as a binary target variable. Now, we move over to the pre-processing process. To prevent data leakage, we remove churn-related fields such as churn reason, churn score, customer status, and satisfaction score. We've also removed irrelevant identifiers like customer ID, zip code, coordinates, and avoid redundancies such as city, latitude, and longitude. And then we've handled missing values. Since the missing value in our dataset is only categorical features, we've only given them with no type given or no offer given. Next, categorical variables were encoded using one-hot encoding. Decision tree did not require scaling, while naive Bayes and ANN used standard scalar. Smooth was also applied to address class imbalance, improving the model's ability to detect churners. Here's our pre-processing pipeline. And then we have the modeling overview. We evaluated a three supervised model in total: decision tree, naive bias, and artificial neural network, as I've explained before. Each model was tuned and trained using the balanced data from this mode, and performance was evaluated using balanced accuracy, recall, precision, and F1 score. Here we see that naive bias contains the highest balance score accuracy. Next will be explained by my friend Firdaus.
Okay, thank you, Rafi. Now let's move on the most anticipated part of our project, the result and model performance. So we evaluated our three models using precision, recall, F1 score, and balance accuracy. If we look at the recall column, this is where it get interesting actually. In churn prediction, recall is our most important metric because it measures how well we catch customers who are about to leave. The decision tree score is 0.68 and the ANN score is 0.79, but knife bias came out on top with a recall of 0.82. Next, we want to understand why we analyze which features each model considered the most important. Next, it's next. Nah, on the left, the decision tree identifies the contract month to month as the number one risk factor. And on the right and center, both knife bias and MLP or ANN highlight that contract 2 year as the strongest feature, viewing it as a signal of loyalty. Next, even though these models use different mathematical approaches, they all agree on one major fact that contract type is the strongest determinant of churn. Next, like this, contract type. Second is monthly charge, and the third is internet type, and fourth is tenor. Next, next. This is the visualization and interpretation of our three method. First is decision tree with max depth is 2. Next, this is the future importance of decision tree with the first is contract month to month. Next, this is the confusion matrix. Say 523 is a loyal customer are correctly predicted to be loyal, and the 72 churn customer are predicted to be loyal escape detection. Next, this feature of naive bias, same here with contract 2 year, which is contract type. Next, naive bias matrix. Next, this is the future importance of next. This is the confusion matrices of ANN. Okay, next. So, what the conclusion? Naive bias is the recommended model for churn detection due to its superior recall, 82%, and the second is ANN delivered the most balanced overall performance. And the integrated AI approaches successfully identified actionable drivers. Contract type is the primary churn lever, followed by referrals code and service type. And the next. So for based on this data-driven findings, we have formulated three strategic recommendations for the business. First is promote long-term contract. Since monthly contract are the biggest churn driver, we should incentive customer to switch to 1 year or 2 year plans. The second is investigated fiber optic services because our analysis show that fiber optic users are prone to churn. We need to investigate if this is due to pricing or technical stability. And the third is deploy the naive bias model, of course. Then next, like this. Okay. That concludes our presentation on the comparative analysis of supervised learning models. We hope this insight demonstrate how AI can be effectively solve real-world telecom challenge. So thank you for your attention. And yeah, thank you.